Hello viewers, welcome to the online course on domestic equipment maintenance. Today I will start the session with another electrical heating appliance that are electric toaster and hair dryer. In the previous session of this module, we have discussed on various aspects of induction cooker. So the basic objectives of this lecture are to know the basic construction of a toaster and hair dryer, to understand the functioning of a toaster and a hair dryer, then to explain the maintenance process, and the fourth objectives of this lecture is to familiarize with the common technical problems encountered in an electric toaster and a hair dryer. Now let us move to the introduction to a electric toaster. Electric toaster is a portable domestic appliance designed specifically for toasting slices of breads. The bread is inserted in the toaster, heated at desired temperature until it achieves a golden brown color. The length of a toasting process is established in advance through the configuration of a built-in control mechanism. Its utility extends to both households and commercial establishments such as restaurants and hotels. The advantages include labor and time saving, easy maintenance, and a contribution to maintain a neat and organized kitchen. The electric toaster is operated at 220 volts AC power supply, and its average power consumption is 1200 watt. The electric current flows through the wire plugged into the domestic electricity supply into the toaster. It flows through a series of thin filaments that are linked and appropriately distanced to effectively toast the complete surface of the bread. The filaments are also thin that they glow red hot when the electricity flows through them. Like a series of small radiators, the filaments beam heats towards the bed in the toaster. The steady supply of heat facilitates the swift cooking of the bread. With filaments lining both sides of the toaster's interior, the two sides of the bread are concurrently cooked. Dear learner, now let us discuss the internal components of a toaster. The internal components of the toaster includes a heating element, control mechanism, bread rack, spring, heat sensor, crumb tray, lever, electromagnet, and browning control. The various parts are constructed from a variety of metals and molded plastics. Screws, nuts, bolts, and washers are used to join the parts together. Now, filaments or heating elements. These are thin wires made of materials with high electrical resistance, that is nichrome wire. Nichrome wire is an alloy of nickel and chromium. It has two features that make it a good producer of heat. Nichrome wire has a fairly high electrical resistance compared to copper wire, so even a short length of it has enough resistance to get quite heat. The nichrome alloy does not oxidize when heated. Iron wire would rust very quickly at the temperature used in a toaster. These nichrome wire are usually fixed onto a plate through which heat is radiated to the bread placed in the toaster slot. When electricity flows through them, they heat up and emit thermal energy. Next, control mechanism. This includes a thermostat and timer that regulate the toasting process. The thermostat maintains the desired temperature while the timer controls the toasting duration. Bread rack or slots. These are the compartments where you insert the slices of bread for toasting. They are designed to hold the bread securely and position it close to the heating elements. Lever or button. The toaster has a lever or button on the exterior of the toaster. It is used to lower and raise the bread slices into the slots. It is also responsible for initiating and stopping the toasting process. When you press the lever down, it lowers the bread into the slots and simultaneously completes the electrical circuit to start the toasting process. Crumb tray. Positioned at the bottom of the toaster, the crumb tray catches any crumbs or debris that fall during the toasting process. This makes it easier to clean the toaster. Insulating and casting. The toaster's casting is usually made of heat-resistant materials that help contain the heat and prevent external surfaces from becoming too hot. Insulation helps direct the heat towards the bread. Circuitry and wiring. The toaster contains wiring to deliver electricity to the heating element as well as the control circuitry that manages the thermostat and timer functions. Bread lift mechanism. This mechanism raises the toasted bread slices above the slots when the toasting cycle is complete. It allows for easy removal of the bread without the need of a manual handling. These components work together to create a controlled heating environment that efficiently toasts the bread slices. Dear learner, having learned about the internal components of an electric toaster, let us now discuss the operation mechanism of it. The toaster works by converting electrical energy into heat energy to toast slices of bread. A toaster uses infrared radiation to heat a piece of bread. When we put the bread in the slots and the power cord of the toaster is connected to the power source, the coils of the heating element glow red by producing infrared radiation. The radiation gently dries and burns the surface of the bread. Two mica or nichrome sheets line either side of the slot. The metal holder rides up and down in the slot to rise and lower the bread. When you push down the handle, the plastic bar presses against the contact and applies power into the circuit board. The power runs directly through the contacts to the nichrome wires to start toasting the bread. A simple circuit made up of transistor, resistor and capacitor turns on and supplies power to the electromagnet. The electromagnet attracts the pieces of metal on the handle, holding the bread in the toaster. The simple circuit acts as a timer. A capacitor charges through a resistor, and when it reaches a certain voltage, it cuts off the power to the electromagnet. The spring immediately pulls the two slices of bread up. In the process, the plastic bar rises and cuts off power to the toaster. Then you would tip the toaster upside down to get the toast out. Dear learner, let us now go through some maintenance process of an electric toaster. Number 1. Switch the power off and remove the plug from the wall of the power outlet. Number 2. Let the toaster cool down fully before attempting any cleaning operation or storing away. Next, from the rear of the toaster slide the crumb tray out and it should be emptied and cleaned after each use. Next, dry thoroughly before sliding back into the case of the toaster. Clean the exterior of the toaster after the unit cools. Wipe the outer surfaces with a soft damp cloth. If necessary, use a little dishwashing detergent. Do not use abrasive cleaners or scrubbers and do not immerse the toaster in water. After cleaning, return the crumb tray to the toaster. Be sure the cram tray sets properly by pressing firmly into the place. Do not operate the toaster without the cram tray properly installed. Let us now try to understand some common technical issues or problems that can occur with toasters. Common technical problems of a toaster includes uneven toasting. Uneven toasting arises when one side of the bread becomes more toasted than the other. This can result from unevenly positioned heating elements or a thermostat that is not functioning correctly. Bread getting stuck. Bread getting trapped refers to instances where slices become stuck in the toaster slots. This occurrence can be attributed to a malfunctioning lever mechanism or the use of excessive thick slices of bread. Burnt toast. Burnt toast may arise if the toaster's timer or darkness control experiences a malfunction, potentially causing excessive toasting and resulting in the bread becoming burnt. Toaster does not pop up after toasting. Failure of the toaster to pop up after toasting can be attributed to either a mechanical issue with the toaster or an electrical problem within the circuitry. The mechanical issue could arise from breadcrumbs obstructing the spring in the latch, preventing proper pop-up. On the other hand, the electrical problem, that is faulty wiring, a damaged power cord, or problems with the electrical outlet can lead to the toaster not receiving power or functioning intermittently. A defective thermostat causes falling to signal the electromagnet to deactivate and release the toaster slots. Faulty thermostat is also an issue for which the toaster cannot read the temperature and properly cut off the circuit. The next issue may be no toasting or the toaster not turning on when plugged in. When the toaster does not heat up at all, it might be due to a faulty heating element, a disconnected wire, or a malfunctioning thermostat. To solve this issue, first check the power cord. If there is a damage to the wire, replace it with a suitable wire. If there is no issue with the power cord, then check for faulty wires inside the toaster circuit. Uneven browning. If the toaster's heating elements are damaged or worn out, they might not produce consistent heat, leading to uneven browning or toasting. Safety concerns. If the exterior of the toaster becomes unusually hot during use, it might indicate a malfunction in the insulation or temperature regulation system, posing a safety risk. Take the toaster to a technician to find the fault with a complete checkup of the appliance. The next issue may be worn cram tray. If the cram tray is damaged or worn out, it might not effectively catch crumbs, leading to a mash and potential fire hazards. It is important to note that dealing with electrical appliances, including toaster, can be potentially hazardous. If you are not familiar with the toaster repair or electrical work, it is recommended to seek professional assistance or replace the toaster if the issues persist. Dear learner, at the end of the discussion on the construction, operation, maintenance, and common technical problems that may occur in an electric toaster, we are going to test our learning by attempting the given questions. Dear learner, thus we come to the concluding section of an electric toaster. So, in conclusion, the electric toaster is a widely used domestic appliance that enables us to prepare toasted bread. Its operation revolves around the conversion of electrical energy into the infrared radiation. The toaster comprises essential components including heating element, control mechanism, and safety features. Like any other appliances, the electric toaster requires proper care and maintenance to continue functioning optimally. Regular cleaning, caution with abrasive materials, and adherence to safety guidelines contribute the toaster's longevity and consistent performance. Well, dear learners, as we have completed our discussion on electric toaster, we will move towards another electrical heating appliance, which is hair dryer. Hair dryer, also known as a blow dryer, is an electrical device used to dry and style hair. Hair dryer is used to a variety of brushes and combs to achieve different hairstyle. It has become an essential device in personal grooming routines. It can operate at 120 volt AC power supply, and the power consumption is in between 1500 to 2000 watt. Let us now discuss the basic parts of a hair dryer. A hair dryer consists of various components that work together to provide the desired airflow and heat essential for both drying and styling hair. The basic components are: number 1, motor. It is the heart of the hair dryer. The motor powers the fan that generates airflow. It is located near the back of the dryer. Heating element. The heating element situated within the enclosure of the dryer is usually made of nichrome wire. When electricity passes through it, the wire heats up, warming the air that flows through the dryer. Air intake vents. These vents are usually found on the back of the dryer. It facilitates the entry of surrounding airs into the device, which is essential for generating the airflow. Filter. Some dryers include a filter to prevent dust and debris from entering the appliance through the intake vents. The filter can usually be removed for cleaning or replacement. Fan. The fan is connected to the motor that draws in air from the intake vents and forces it over the heating element. This process heats the air, which is then expelled through the nozzle. The next component is nozzle or diffuser. The nozzle of a hair dryer is an attachment at the front that directs the airflow onto the hair during drying and styling process. Control settings. These buttons allows users to adjust the dryer's heat and speed settings according to their hair type and desired style. Cord and plug. The power cord connects the hair dryer to an electrical outlet. It is usually attached to the back or bottom of the dryer's handle. Handle. The grip of the handle offers users a convenient way to hold and control the dryer as they shape their hair. Next is housing. The housing envelopes and safeguards all internal components, furnished both protection and structural stability of the hair dryer. So, dear learner, let us now go through the operation mechanism of a hair dryer. Hair dryer needs only 2 parts to generate a blast of hot air that dries your hair: a simple motor driving fan and a heating element. Hair dryers use the motor driven fan and the heating element to transform electrical energy to convective heat. The whole mechanism is really simple. When you plug in the hair dryer and turn the switch to on, currents flow the hair dryer. The circuit first supplies power to the heating element. The current then makes the small electric motor spin, which turns the fan. The centrifugal movement of the fan blades draws air in through the small round gap in the lap in the side casing of the hair dryer. The airflow generated by the fan is directed down the barrel of the hair dryer over and through the heating element. As the air flows over and through the heated element, the generated heat warms the air by forced convection. The hot air streams out the end of the barrel. The fan rotates rapidly, drawing more air and increasing the airflow. Let us now discuss some troubleshooting of common problems. The common issues encountered with hair dryer include no power or not turning on. If the hair dryer does not heat up, check the power cord, plug and outlet for any damage or loose connections. Verify if the hair dryer has a reset button. Press it if necessary. If none of the above works, there might be an internal electrical issue and professional repair might be needed. Overheating and burning smell. If the hair dryer heats up excessively or emits burning smell, ensure the air intake and exhaust fans are clean and unobstructed. Check for a clogged air filter or dust accumulation inside the dryer. Clean and replace it. Avoid using the dryer on the highest heat setting for prolonged periods to prevent overheating. Weak airflow. In the case of reduced hair dryer airflow, examine the air intake fans for any blockages or derbish, clean them if necessary. Also check the nozzle and attachments for obstructions, remove any hair or derbish. Strange noises. If the hair dryer's motor is producing unusual noise, inspect components such as the nozzle or attachment to ensure they are securely fastened. It might be damaged and require professional attention. The next issue may be blowing cold air. If the hair dryer blows cold air, check the heat settings. Test the heating element with a multimeter to check for continuity and proper resistance values. If the heating element is malfunctioning, take the hair dryer to a technician. Dear learner, let us now discuss some electrical safety considerations. Avoid using the hair dryer near water or while bathing. Number 2, do not immerse the hair dryer in water. Next, if you notice exposed wires or any signs of electrical damage, stop using the dryer immediately and have it inspected by a professional. Always unplug the hair dryer from the electrical outlet after use. Leaving it plugged in, it can pose a fire hazard and increase energy consumption. Next, to prevent overheating or a burning smell, ensure that the air intake and exhaust fans are clean and unobstructed. Regularly clean or replace the air filter too. Store the hair dryer in a dry, clean place when it is not in use. Okay, dear learner, now since we have almost come to the concluding section of the session, we can now attempt a few questions to test our learning. Alright, dear learner, after attempting these questions, now we come to the end of the session. Let us summarize what we have discussed about a hair dryer. A hair dryer is a fundamental grooming appliance that employs heated airflow to rapidly dry and style hair. Its construction involves essential components such as the motor, heating element, and airflow control mechanisms. The working principle of a hair dryer involves the conversion of electrical energy into convected heat. Safety considerations are essential to prevent accidents such as electrical mishap or overheating. Regular maintenance, including cleaning the air intake vents, filters, and attachments, and proper inspection are essential to ensure optimal performance and prolongs the appliance lifespan. So, we come to the end of our today's discussion on electric toaster and hair dryer. Hope you have gained insight into some fundamental aspects of these commonly used electrical heating devices. Feel free to share any questions or queries you may have. Thank you very much.